Hi guys, in today's video let's understand about IPsec protocol. It's one of the security protocol used for encryption, hashing, authentication and many more things. It's one of the protocol which is used over the VPN communication as well. Let's say it could be site-to-site VPN, multi-site VPN, a remote access VPN. Not only a VPN, wherever I need security at IP layer, right? I can go with IPsec protocol. And IPsec is not only a protocol, it's a suite of protocols. Under the IPsec, we have multiple protocols like IKE, ESP, ISACAMP, Oakley. There are multiple other protocols which comes under the IPsec. That's why we call it as a suite of protocols, not only a protocol. Now here in today's agenda, if you see, we have IPsec protocol, IKE v1, IKE v2 and comparisons and all. But in today's video, if I start discussing about all these topics, it will be a long video. So in short, today I'll be discussing only about the IPsec. So let's deep dive into a IPsec protocol. Now here if you see, what was the reason for having an IPsec? Multiple reasons. See, multiple layer of securities were required. I mean, whenever packet passes on the internet, right? Let's say, for example, if I have to communicate from one branch office to other branch office or from one headquarter to another branch offices, in between we have an ISP. So ISP is the method of communication. So over the ISP, if I communicate with any with any data, if I want to send it from one location to other location, definitely our data are not secure, right? So we need to implement a security over the ISP whenever we send the data. This is where IPsec comes into a picture. Like we create a VPN, site-to-site VPN, and we implement IPsec over the tunnel, right? That's what we do with the IPsec. Right. So same thing here, multiple strong authentication methods required, anti-cloning, prevent connection hijacking, man in middle. Let's say, for example, I'm communicating between Delhi to Bangalore. In between, someone hijacks your session and does some manipulation to your data, right? So if I want to prevent such things, I need to implement some protection. I need to implement some security to our data. This is where IPsec comes into a picture. So in today's session, especially I'll give you visibility on VPN part. On a VPN, when I implement a IPsec, then what happens, right? So let's understand. When I come to IPsec, in a IPsec total, we have 12 RFCs. These are the total RFCs that you can see. As I told you, in a IPsec, we have a multiple protocols, right? We have ESP protocol, we have protocol, we have IKE, NAT-T, so many things are there. You can see these are the total RFCs inside your IPsec. So any particular protocol, if you want to know, you can prefer going for this RFC. Let's say you want to know ESP, or you want to know about IKE v1 or NAT-T, anything, go directly for the RFC. That will give you the perfect information about this particular protocol itself. This is where RFC comes into a picture. Okay, so in IPsec, these are the total RFCs. Now let's see next part. Now here you can see these are the branches of IPsec. Now this is the best way of understanding IPsec, guys. Okay, when you go through any books, when you go through any sites, blogs and all, right, it becomes very difficult to understand actual way of the IPsec, how to understand IPsec properly. So let me make it very easy for you guys to understand in today's session. So here you can see we have IPsec, and IPsec has three protocols, like we have IKE, ESP and right? IKE is not actually a protocol, it's internet key exchange. It's a method of exchanging the key, but it also uses a protocol inside. That's why we count it as a protocol itself. So in short, we'll call it as a protocol. So here you can see IPSec has IKE and it has ESP protocol, it has AH protocol. ESP protocol, encapsulating security payload, is the protocol full form, and it has protocol number. It means it's a IP layer protocol and it has a protocol number 50. It supports both encryption and hashing. In a real time, if I want to protect the data, if I want to implement encryption and hashing, I'll use ESP protocol, not a AH protocol. Reason, AH protocol supports only hashing, does not do an encryption. That's why we use ESP in a real time, not AH. Okay. Now, AH has a protocol number 51, right? But used only for monitoring purpose. Let's say, for example, you might be thinking, if it does not support encryption, then why should I use it for, a real time, right? How can I use it for data protection? It's not about our data protection, guys. We are not using AH for data protection. Let's say we use it in a initial phase. Let's say I created some tunnel. I want to see how the packets are passing through. Do I have multiple headers inside the tunnel or what, right? Is there a repetition of IPv4 headers or GRE headers? How can I reduce the headers and all? I need a visibility inside a packet, right? So in such case, I use AH, basically at the initial phase of VPN, right? When we are creating a tunnel, before, putting in a service, we basically test our tunnel. At the testing phase, if I want to see how the tunnel packets are passing, AH would be the best protocol to see, right? But once you see everything is good, in a production environment, you would go with ESP, you would not use AH protocol, right? So these are the differences between ESP and AH. Once again, I'll tell you a summary. ESP supports both encryption and hashing. AH supports only hashing. That's why we don't use it in a real protection. We use only ESP protocol. Now, coming back to IKE. One more thing, guys. This video will be very useful for your interview perspective. Okay, I'll create a series of video on it. So today is a starting day of your IPSec protocol, right? There are many more things in depth at the packet level I'll be discussing with you guys. Okay. If you have any queries, you can drop your comments, right? I'll try to answer all those queries. Now here, coming back to IKE, IKE has two versions, IKE v1 and IKE v2. IKE version 1 is now being replaced in a market with IKE v2 and all, because IKE v2 is now supporting more algorithms, latest algorithms and all for encryption and hashing. Okay, but that's a different thing. Now let's see here. IKE v1 and IKE v2 has two phases. Okay, so you can say IKE v1 has phase 1 and IKE v2 also has a phase 1 and phase 2. So under the IKE v1, you have phase 1, phase 2. IKE v2 also has phase 1 and phase 2, right? Now, each IKE version will have, again, you can see here, IKE version 1 has phase 1 and phase 2, and under the IKE phase 1, again I have main mode and aggressive mode. I mean, guys, see here, not in each IKE mode, only in IKE v1, we basically have mode concept. You see this mode concept? This mode concept will have only in IKE v1, not in IKE v2. All right. So here, IKE v1 has phase 1 and phase 2, right? And phase 1 has again two modes, main mode and aggressive mode. This is phase 1, and again you can see here, let me remove this. You can see here, phase 1 has two modes, main mode and aggressive mode. And when it comes to phase 2, it has only one mode, that is called quick mode. But when it comes to IKE V2, understand guys, IKE V2 only has a phase 1 and phase 2 parameters. It does not have any mode concept like main mode, aggressive mode, quick mode. We don't have this concept in IKE V2. All right. Now, coming here, you can see your phase 1 is actually called as a control plane, and phase 2 is called as a data plane. Understood? Phase 1 is used for key negotiation, cipher communications, like cipher exchange, you can say, not a communication. Let's say haggle process exchange, key exchange, right? After that, phase 1 authentication. All these things will happen in a control plane. It will not happen in a data plane. Real data is carried by data plane. Real data is not carried with phase 1, guys. Okay, so phase 1 is basically known as a control plane in a VPN, and phase 2 is known as a data plane. In short, if I tell you, phase 1 is used for negotiating haggle process, is used for key exchange, and is used for authentication. So once your phase 1 is established, once your phase 1 works or is established, then only phase 2 negotiation will happen. Understand, in a real time, whenever you guys are exchanging a data, whenever you are negotiating for a VPN between two sites, right? That time, phase 1 negotiation is important. If phase 1 negotiation is not done, then phase 2 negotiation will not happen, right? So here, first thing is you have a phase 1 and phase 2. Phase 1, as I told you, it's a control plane, and phase 2 is a data plane, right? Now, this phase 1 and phase 2. Phase 2 is used for carrying a data. It will carry your real data, right? Now, this phase 1 and phase 2, you can see here phase 1 and phase 2, right, is carried by a protocol called ISACAMP. Now, if you see names here, in IKE V1, phase 1 is called ISACAMP. It's a name given, ISACAMP. And phase 2 is called IPSec. Let me take you to a previous slide where you can get the clear concept on this name. Okay. So if you see here I have names mentioned. Okay. Phase 1, in IKE V1, phase 1 name is given ISACAMP and phase 2 name is IPSec. Guys, again, don't misunderstand with the protocol. Okay. These are the names given in the IPSec. Okay. Phase 1 name is ISACAMP, phase 2 name is IPSec. Whereas in a IKE V2, phase 1 name is IKE SA init and phase 2 name is IKE auth. These are the names, these are not the protocols. Understood? Now, coming back to our next slide, if you see here, same thing I was discussing here. So, either it's a IKE V1 phase 1 or a phase 2, or it's a IKE V2 phase 1 or a phase 2. In a real time, the message exchange of these two phases of IKE V1 and IKE V2s are carried with ISACAMP protocol. Okay, ISACAMP protocol, which uses UDP port number 500. Always understand, ISACAMP is the protocol which is used to carry phase 1 and phase 2 message exchange between the two sites. Okay, so here either it's a IKE V1 or it's a IKE V2. Basically, the messages are carried by ISACAMP protocol, which uses UDP for source and UDP UDP port number 500 for source and for destination. Now same is used in IKE v2 as well. Now what is this message exchange? Why is this message exchange required? If you think about it, I'll tell you. In a previous slide what I had shown you here. See guys, I told you right here that IKE v1 has a phase 1 and phase 2, and here again IKE v1 phase 1 has main mode, aggressive mode, and phase 2 has a quick mode, right? So in a real time, whenever I am establishing a tunnel using IKE v1, in such cases I can make a combination of two modes. From phase 1 either I can take main mode, quick mode, or I can take aggressive mode or a quick mode. So most of the time we use this one, main mode and a quick mode combination. In a main mode we have 6 message exchanges, and in a quick mode we have 3 message exchanges. In total we have 9 message exchanges. It means if I want to establish a tunnel using IKE v1 with a main mode and a quick mode, I need to exchange 9 message exchanges. That means in main mode we'll have total 6 message exchanges. Control plane, main mode means control plane, and quick mode means data plane. Here I'll have 3 message exchanges. So when these 6 plus 3 message exchanges are actually successfully exchanged between the two sides, then only tunnel is created, then only your real data is being protected by ESP protocol. But till these 9 message exchanges are done, it uses IPSec UDP port number 500 for source and destination. Understand this part. This is what I was trying to tell you guys. When you're using a tunnel between two sites, it will use 2 phases of negotiation. Phase 1 control plane, phase 2 data plane, and these 2 phases message exchanges, that 9 message exchange which I had shown you, right? That 9 message exchanges will happen under UDP port number 500, and UDP port number 500 means which protocol? IPSec protocol, right? So overall moral of the story is, when I create a VPN between two sites using IPSec, I need to use either IKE v1 or IKE v2, and tunnel will be negotiated in 2 phases, phase 1 and phase 2. Phase 1 is control plane, phase 2 is data plane, but this message exchanges will happen under the IPSec protocol using UDP port number 500 between source and destination. So this was today's short video for you guys. Okay, in a next class I'll explain you guys about main mode message exchange, aggressive mode message exchange, comparison between them, quick mode, and also IKE v2 message exchanges I'll be explaining you guys. See you then. Take care.